The objective today is to explain the uses for relational database models. Now, no crying in this lesson. Is just something we got to get under our belts. It's not too bad of a lesson, just a lot of vocabulary. So the first thing we'll do is I'll just explain what it is. Then let me give you some bad jokes and poor connections to try to think about when approaching relational database models. After that, I'll just start digging into the vocabulary words like tuples and attributes and a few others. And then I hope to just provide you some useful examples as you move forward. So what I'm saying on this slide is that this is just one of those lessons where you'll probably want to write in complete sentences because doing so should help you with your comprehension. We're using so much vocab here that writing it out, I hope it sticks after that. And to keep our eye on the prize here, remember I try to prepare students for careers, not necessarily college. And if you were wanting to bypass college, one thing for you to do might be take certification tests. And I've heard from several people that a lot of these tech certs are just vocab tests, and the ones I've taken, I feel like that's 50% true. I don't think I would have passed the ones I've taken if I didn't really have a grasp of the vocabulary. So here we go. A relational database model organizes data into one or more tables. These are the relations. And as you already know, tables are made of columns and rows. The key here in computer science is we need a unique key to identify each row. So to mix in some vocabulary, rows are also called records or tuples. A little bit of a summary of the definition of a relational database model is just the idea that these are basically like Venn diagrams, or I should say they give us the power of Venn diagrams without Venn diagrams. Teachers are famous for loving Venn diagrams. I wish they were called something cooler like a Venom diagram. But the concept of looking at groups or sets of things and figuring out their relationship to each other, even if it's really complex like this one, this is an important thing to do. It looks like here we have Greek letters, Russian letters, and then normal, or I should say English letters. I say normal because I speak the language. And there are some Greek letters that have the same symbol as our English letters, and same with the Russian and the English ones. And then, of course, there's just a whole slew of letters that all three languages have. So relational databases giving us the power of Venn diagrams, and here's a fun way to think of this maybe. RD helps us get rid of VD. So relational databases help us avoid that whole Venn diagram scenario. So here's your first relational database model. As you can see here, there are three different unique tables that have things in common with each other. This is the relationship. So here the key is over here in another column. If I'm looking for a particular book, I could search by its ISBN number, or I could search, I don't know why I would do this, but search by its publisher ID number. But more likely, I'm searching by maybe its author name, which will be connected to probably some sort of author ID number. Why? Because there may be an author with the same name as another author. So that's sort of your first lesson here, is the key needs to be unique. So let's take this one piece at a time. I said the relational database model organizes data into one or more tables. So your think right share here is, what is the relationship between a school and a student? If I go up here to my example, schools contain students, and so a school ID is a number that you could find in a student table. I might be specifically looking for certain schools, but then when I'm looking at certain students, there can be more than one student in the same school, so this would have the same number, obviously. I said before, you need a unique key identifying each row. So it's natural for me to go from this table to this table, but in this scenario, I'm not going from here to there. So this question's a little tricky. What is the unique key in the student table? That would be this student ID right here. And you can always assume if you see just like ID, you can take the table name and say student ID. Over here it says date of births. Well, whose date of birth? Go to the table name, student date of birth. So let's go back to this one we looked at before. Right here, what is the unique key in each table? And I'm not going to spend any time trying to trick you guys. You can look here at the first column and say, are these keys unique keys? If the answer is yes, then we're doing good. Over here, the author ID should be unique, and so should an ISBN. Would it ever be appropriate to put a date over here in the first column? No. Going back to this table, columns are also called attributes, so generally each table or a relation represents one entity type, it's called. So my question on this slide, what attributes do you see here? In the first table, I see an ID and a name attribute. What type of ID do I see? Not a student one, I see a school ID. Going back to rows now, rows are also called records or tuples. So think right here, what is the tuple in the first table? To give you more details about rows, rows represent something called instances. So there are instances of that type of entity, and these columns, they're representing values that are attributed to the instance. So see how these words can be used in a sentence reasonably? So for instance, student 500 has an attribute of the name Matt and is attributed the number 5554141 and so on. How many instances do you count in the takes course table? And when you look at tables like this is called an ERD model. It says a diagram showing the possible links between the tables in a simplified relational database used by a library. So these key fields are foreign keys in the linked tables. In other words, these fields have a lot of information that go with them. So my question, what are the values of the attribute book ID? Every book should have an author, a title, a synopsis, and a genre. So don't be scared of this. We're not going to go deeply into the coding or anything like that. But here is how you can, from a text editor or the command line, create a relational database. Here's a better look at tuples, especially in Python. My students who have taken me for the JavaScript class, they know how to create lists or arrays in JavaScript. Python is particularly famous for their tuples, but in Python's case, a tuple means that this is an immutable thing. Immutable being the values do not change. Once you create tuple 2 will always be the numbers 1, 2, 3, 4, and 5, and in that exact order. So let's wrap up this lesson. It says each row in a table has its own unique key. Rows in a table can be linked to rows in other tables, and you do this by adding a column for the unique key of a linked row. It is helpful for you to know that part of processing in terms of the computer, part of the processing involves consistently being able to select or modify one and only one row in a table. Therefore, most implementations have a unique primary key. And a nice visual for you right here, there's a little key. There's a little key picture showing you the start of this row. And to preview lessons coming up, we'll learn about SQL. Some people call it SQL. But here's all that vocab for you. In SQL, you'll hear somebody say row, but if somebody is more mathy or working with just the relational database model, they might call something a tuple or a record. I think especially in business, you'll hear people calling a row a record. And if you liked today's lesson, you might want to study something called set theory. Set theory is a branch of mathematical logic that studies sets, and informally, these are just collections of objects. And studying set theory might lead you into studying functional and or versus object-oriented programming. You can have some functional programming languages acting as an OOP language and vice versa. Just depends on your programming style. And that's why I put the verses there, because people could definitely argue about this subject. I mean, I did say style, not sanity. Some people's style is to be insane, I think. So that was it for the lesson. Your demonstration of learning is to answer this one question, and the question is, what are relational databases why are relational databases useful?